let's assume anything that uses electrical energy, right? So imagine a flashlight. So the way you store electrical energy in a flashlight is that you have the flashlight and you open it up and there's a battery inside, right? So the battery is separate from the flashlight. That's how we store energy for electric cars. That's how we store energy for phones, for laptops, that you have the battery, which is separate from the structure, right? So electric car has a lot of batteries. In fact, batteries constitute a large part of the weight of an electric car. So if you want to go further, or if you want to go faster, or if you want to be able to carry more load, as in a UAV, you're competing with the amount of battery that you have. Now imagine, in case of a structure, instead of storing the energy in a battery, you could modify the structure itself to store energy in the structure. For example, if you could modify the hood of a car, or if you could modify the frame structure of a car, or the door panels of a car, so that they start now working as the electrical energy storage device. If you can do that, then you can reduce the amount of batteries that are required to store that amount of energy. So if you reduce the amount of batteries that are required, the weight goes down because of the batteries. Now you can have more range. If it's a UAV that is going to pick up something and drop off something, then you can have more payload capabilities because you're not carrying as many batteries on board. So our entire concept revolves around taking a structure that usually just it's a load-bearing structure, and converting it so that it does what it did earlier. That means bear loads like the wings of an aircraft, but it also stores electrical energy inside that structure. So that's where our modification comes in. So that's why we call these, structural batteries or structural supercapacitors. Then there is potential for not only licensing this technology or starting up a company local in the area, let's say that ends up sub-licensing technology from OSU to take this to the next step. And the idea would be then, you bring it to a prototype level, you figure out how you integrate this into other companies that are in the state that are, let's say, focused on UAVs, or other companies that work with the Navy or the Air Force or Army for DoD applications, grow it into an application, and then spin this off either as a company or as a licensed product or as something that's manufactured and sold. So what the DoD funding does is it provides funding for the fundamental research that will then drive the innovation, that will then lead to the technological commercialization of this technology and so forth. Mm-hmm. That's why it's critical, because now you have this assurance that we are interested in you, we are willing to invest in the fundamental aspect. The other aspect is that the DoD can also be a client. So not only are they funding the fundamental basic research, but it is for a DoD application. So there is an automatic translation from the fundamental research to something which is much more applied. And that's where I think the benefit comes to Tulsa, is that not only does it promote the fundamental research at the Helmerich Research Center, allows us to attract good talent, allows us to train students to work in an area that is at the forefront of energy storage technology, but it also then leads to commercialization, which is direct economic